Let's talk about finding the domain of a composite function. First off, reminding ourselves that the domain is the x's that will give me a real number output, will give me a real value for y. If I have context, I might have to restrict that further, but for now we're going to stick with the general cases. There were two main situations that we were concerned with, and those are fractions, because we cannot let the denominator be 0, and square roots, because we don't want a negative value underneath there. Those are imaginary. So those are the two things I'll have in the back of my head as I go through this. Now, because I'm looking at a composite function, that means I'm looking at f of g of x. So I'm going to first take my x and put it into g. So the first step in finding the domain of the composite is what works in g? What works in that first function? Are there any exclusions based on g of x? Okay, if we get through g of x, then we're going to take that answer and we're going to put it into f. So one way of stating the second step is any x that makes g of x a number that makes f of x undefined. That can be kind of confusing, so I'd rather say it this way. Let's look at the first function we go into, in this case g of x, and then the final function that we have, our final composite function. So what x's do I have to exclude for the first function? What x's do I have to exclude for the final function? And that'll accomplish the same thing. All right, let's take a look at a couple examples. So I have f of x equals 6 over x, and g of x is 1 over 2x plus 1. Finding f of g and its domain means I'm first going to go ahead and figure out what that function looks like. So if it's f of g, that means, remember, that we're going to take the g here, and whatever that is, we're going to put it in place of. So you wipe out that x and you put this expression there instead. So we get 6 over the 1 over 2 over x. 6 over the 1 over 2x plus 1. Now, a fraction is really a division problem. So it's saying 6 is being divided by that fraction, which is equivalent to multiplying by its reciprocal. So when I do that, I can ignore the denominator of 1 and multiply it out, and I get a very simple expression of 12x plus 6. You always want to simplify as far as you can. So now let's apply our steps. So we look at the first function. Well, it was f of g of x. So the first function was this fraction right here. So I know I have to be worried about the denominator. I set it equal to 0 and realize if I subtract 1, divide by 2, I don't want x to be a negative 1/2 because that'll make this denominator 0. So my first restriction is x cannot be negative 1/2. Then I don't look at f, I look at the final function. So the first one and the final one. And my final composite function that we simplified here was simply 12x plus 6. There's not a fraction there. There's not a square root there. So there's really no exclusions or restrictions on x. So my final domain is going to just have to restrict and exclude the negative 1/2. In interval notation, that means it's negative infinity up to the negative 1/2 with the parenthesis to show we get close but not include, union, parentheses, negative 1/2 to the positive infinity. Now, if we reverse this and find not f of g, but g of f, that means we're going to take the f here and put it in place of the x in the g's formula. It looks like this. So g of f of x is going to be g of the 6 over x. So that goes down here in place of the x that was there. That's a 2 over 1. That simplifies to 12 over x. Looks kind of messy. We don't like to leave fractions in fractions. And this time I don't have a single fraction down here that I can just multiply by the reciprocal. So I'm going to use an alternate technique to simplify this, and that is multiplying the top and bottom of my main fraction by the common denominator of all the pieces inside. Well, the only denominator we have in there is an x, so that's why I chose to multiply the top by x and then each term in the bottom by x. What that does for me is it cancels this denominator, so we end up with x over the 12 plus x. Still a fraction, but it's a little cleaner looking than the other version. Okay, so our two steps again, look at the first function and then look at the final composite. So in this case, g of f, the first function was f of x. Well, it's a fraction, the denominator is simply x, so that means we can't let x be 0. That one's done. Then we look at the final composite function. We have a fraction this time, so we are going to have a restriction. We focus on the denominator and say, what would make that equal to 0? Well, solving quickly would be negative 12. So now I know I cannot have 0, and I know from the final I can't have negative 12. So I'd have 2 holes punched on my number line, which means my interval form is going to be negative infinity to the negative 12, then negative 12 to 0, and finally 0 to infinity. Let's take a look at one more, but this one's going to have a square root in it, just to review that. So if I have f of x is equal to 3x minus 2, and g of x is the square root of x plus 4, f of g of x means take the g formula and replace the x here. Well, that's going to be f of that, so plug it in, and I really can't do anything with it. It's 3 times the square root of x plus 4 with a minus 2. Okay, you can't multiply a number outside to a number inside a square root. So we leave it. The domain, same 2 steps. What was the first place we went? Well, the first place we went was g of x. We just said that this stuff underneath here has to be not negative. In other words, has to be greater than or equal to 0. So that means x would have to be greater than or equal to a negative 4. When we look at the final composite function, it has the exact same square root in it, so there are no additional restrictions. So my domain is simply going to be from negative 4 to infinity. Now you notice I do have a bracket on this one, because it says x can be greater than or equal to the negative 4. Because when I put a negative 4 in here, I get 0, and the square root of 0 is 0. It's a real number. It's allowed to be included. If we reverse it and do g of f, all right, so this time we're going to take the f of x and plug it in and replace this x in g. So now I have this quantity plus 4, remove the parentheses and combine your like terms, and we're going to end up with the square root of 3x plus 2. Okay, same steps to finding the domain. What's the first function that we went into? Well, the first function that we went into was the f, 3x minus 2. There is no square roots, no fractions, so there are no restrictions. Then we look at the final. And the final does have a square root, so we would set this square root, the stuff underneath here, greater than or equal to 0, and solve that and find that x must be greater than or equal to negative 2/3. So as the interval then, my answer is going to be bracket, because or equal, negative 2/3 to infinity. Let me know if you have any questions.